welcome to this presentation on transcendental functions and continuity. Today, we're going to explore two important concepts in calculus that often arise in both theoretical and applied mathematics. Let's start by understanding what transcendental functions are. These are functions that are not algebraic, meaning they cannot be expressed as the root of a polynomial equation with rational coefficients. In simpler terms, transcendental functions go beyond the usual algebraic functions like linear, quadratic, or cubic functions.
Some common examples of transcendental functions include exponential functions, logarithmic functions, and trigonometric functions like sine and cosine. These functions are essential in many areas in science, engineering, and mathematics.
Exponential function e raised to x describe the growth or decay and appear in the process like population growth and radioactive decay. Logarithmic function such as natural logarithmic are the same inverse of exponential and widely used to solve the equation involving exponential growth or decay. Trigonometric function including sin x and cos x are like that describing wave phenomena.
Was at a point if the following three conditions are met. And what are those? That's why the first is the function is defined at that point. The second, the limit of the function exists as it approaches that point. And lastly, the value of the function at that point equals the limit. If any of this condition is validated,
let's look at this function. To check continuity at x is equals to 2x. A. Check if f of 2 is defined. F of 2 is equals to 4f, so it is defined. B. Find the left-hand limit. Limit of x is approaching to 2 minus f of x is equals to limit approaching to 2 minus x squared is equals to 2 squared is equals to 4. C. Find the right-hand limit. Limit of x is approaching to 2 plus f of x is equals to limit of x is approaching to 2 plus x plus 2 is equals to 2 plus 2 is equals to 4. Since both limits exist and equal f of 2, the function is continuous at x is equals to 2.
Importance of continuity. Why is continuity important? In real-world applications, many models rely on the assumption that functions are continuous. For instance, the smooth motion of objects, fluid flows, and electrical circuits all depend on continuous functions. Discontinuities in real-world phenomena can lead to problems like sudden jumps in behavior, which can be challenging to model and predict.
To summarize, transcendental functions are key players in mathematics and science, and many of them are continuous over their domains. Understanding both transcendental functions and the concept of continuity allows us to build better models, solve more complex equations, and apply these functions to a variety of real-world problems.